Okay, here's the pre-calc. It's part 2 of problem 10-17 because it's a very long problem. So now, so I left off right here, letter E, and letter E said continue to rewrite your equation until it equals 1. Hint, you may need to factor. And then when I looked at the answer key, I saw they wrote it this way, but I'm not very worried about it because if I multiply the top and the bottom by -1, that will turn this positive, that negative, and that positive, and then I can let these two switch places. So it's the same. Oh, oops, it has to say equals 1. Anyway, so there's that. And then letter F. So letter F says, write an equation relating A, B, and C. Move your pencil in the string to the point 0, comma B. I had to make one of these so that I could use it. So what was the length of the string? Does anybody remember? The length of the string is actually 2A. Okay? So if I hold my pencil right in the middle right here, then I've got half of 2A. Like right here, that would be A, and that would be A. And A plus A is 2A. Okay? Now, this thing right here, that's B, right? Because that's the origin. And then, what was I supposed to... This thing, this right here, the focus is at C comma 0. So this is C. And this is a right triangle. So B squared plus C squared equals A squared. Wait. B squared plus... So B squared plus C squared equals A squared. What? I know. You guys think A squared plus B squared equals C squared, but in this case, this hypotenuse is half of my string length, so it's A. Okay, so what did I write down? I wrote B squared plus C squared equals A squared. So that is an equation relating A, B, and C. Now it says letter G. Letter G says letter G says to use substitution, and the equations that I wrote in part E, so this one, and part, where am I? Use substitution on the equations you wrote in part E and F to write the equation for the ellipse using only A, B, X, and Y. So I can only use A, B, X, and Y. So that means I got to get rid of C. So I think I'll rearrange this thing so that I have C squared equals A squared minus B squared. And then it wants me to use substitution. Okay, all right, I can do that. So I'm going to plug in for this C squared right here, I'm going to plug in A squared minus B squared and see what I can do with that. For C squared, I'm going to write like that. Kind of horrible, actually. Oh, I don't have to square it though. It's not that horrible as I thought. So this would be A squared minus A squared plus B squared. So this would be sorry, it always equaled 1. Okay, and then is that the same as my equation of an ellipse? Kind of. I mean, we didn't have any H's and K's in this case. But yeah, with your team, compare the ellipses you constructed. How do the parameters in the equation relate to the graph? Be prepared to share all your ideas. So we'll talk about that in class. But this is the derivation that we were supposed to be doing on 10-17.